Hi everyone, this is Mark from Micros Quads. This is the Martian 3 build. Just wanted to go through a few of the components. This is the 250mm Martian 3, so this can actually take 6-inch props if you wanted it to. I'm going to put 5-inch props on it. Dal Cyclones 5046s. And here is the arms. It comes with a PDB on it. No voltage regulators though, so if you need a lower voltage you'll have to think about that. It also has a bottom plate for the battery straps and so on at the very bottom, dirty plate. Then it has a proper bottom plate that just fits under the arms. Then it has a top plate and some nice roughed up spacers, which is fantastic because it's much easier to screw them on. So what I'm going to put into this is I have an old Flip32 F4 board. It doesn't have anything really on it, but it can take the direct voltage from the battery. And then I have some Racerstar 28A ESCs. They come bare like this. I just left a heat shrink on them. I'll take that off later when I'm putting them on. And it's really easy to connect these up to the battery, or up to the motors and then to the PDB. It comes with some nice silicone cables and stuff, and you know, whatever you use you can use, and then it always leaves you with some more stuff that you can use for other projects and other things. The motors are just these very simple Racing Edition Racerstar motors, BR2205s, 2300 kV. Now what's funny is I have a set of the non-S ones, but actually the trust specs that it gives in the documentation says it's the same, so it'll be interesting to see if this is any better or not. I also have a Rush VTX, which is switchable, which is really great. Really easy to use, and that's nice. I have a Runcam Swift 2 Micros Swift, so this is the new one, 2.3 lens on it, and then it also has an on-screen display, so you can take the full battery power into that, which is great. Here are the camera mounts. I may not use them. I have a small steel mount for the Runcam Swift 2. Here's an XM Plus receiver, which is nice. Tiny little bit I might put a tiny bit more hot glue on those, very easy to replace, rather than having to solder like some of the others. I just have a little power reduction if I want to take it down from say 12 to 5. At least I know then that I'll be getting that consistently. And then this is just the AOMway. This is an RPSMA for the video, and that'll fit nicely onto the top plate. Comes with a nice hole for the connection to the Rush VTX. I will probably put a small strip of lead on this with a buzzer on it, or I may just use a buzzer directly. I haven't fully decided yet. So that's really what it looks like. Quite different than my normal quad. I've had a fairly large quad. Quite a different quad for me, nice and small. Typical builds, these larger, and this is a Nighthawk clone, lots of room inside, lots and big, and very good from a learning point of view. But this one should be more nimble, and therefore really thinking about flying some acrobatics with it. Alright, so I'll be back in a minute and we'll start the build. Okay then, here's the components from the frame, so let's put it together. So there we have the bottom of it put together. So we put these 4 central screws together, and then they got the nuts on the bottom, and then we put these other large screws through the outside hole on the end of the arms, closest to the end of the arm, and then we put the spacers, small risers beneath, all loose, nothing tight at this moment, and then we put 4 larger screws down in the middle spots, and then we connected the nylon spacers to these. Alright. Now just before we go too much further, I'm going to just tune some of these connectors. The pads on the PDB. So again, make sure you do this properly now. Now the other thing that's worthwhile taking some time out to do is just to do some continuity checks. Make sure you haven't joined any of the negatives. Check that there is continuity across the positives. Okay. So now we can put back together the base plate up into the nylon risers. So here's our 4 motors. Just remember that the motors spin in different directions, and although you can change them, it's important, especially with the lock nuts, that you have them in the right direction. So typically going forwards, your motors want to spin in, and at the back your motors want to spin in as well. So that's an anti-clockwise, clockwise, anti-clockwise, clockwise. Okay, let's put them on. So here's the 4 motors just sitting on top of the arms, not screwed in. And remember the ESCs, you just want to put around halfway down the arm. So you need about this length. So what you should typically do is make sure you have the same length with all the engines, all the little motors, and then connect them all up to the ESCs, and then we can start looking at ESCs to PDB. Thanks! Okay, just doing the last one now. Just cutting and taking off the end of each one. It's good if you have a wire snips, or don't do it too long. Okay, and that should be perfect for tinning, and then connecting up to the ESCs. Okay, back in a second. Okay, just going to tin the wires now. Okay, now we've got the motors on, the ESCs connected. Now what we're going to do is just wire up the plus and minuses on the 4 corners to the PDB, and then we'll start to look at the signal wires. Now the ESCs do actually come with servos, but we won't be using those. We'll be just wiring directly to the F3 or F4 flight computer. Okay. So let's wire up the ESCs to the PDB first. So there we go. We have the 3 motor wires to the ESC, then we have the shrink wrap still loose, and we have a positive and negative to the board for each of the ESCs. So now it's going to be time to start putting together the flight controller and the FPV equipment. Alright, let's do it. Just want to show you there as well, I just connected up the signal and ground wires. You don't really need the ground, but just make it a bit neater. I won't be using the servos, I'll just be cutting them to length. Alright, thanks. So next I'm going to tin up some of the areas on the flight controller using this little Flip32 F4. So I'm just going to tin up the area for the S-bus receiver, for the 4 signal wires, for the LED buzzer, and VBAT full power from the battery. So let's do it. Okay, so we've done a bit of soldering. We've put the buzzer and the LED strip onto the first 2 parts here, and again the signal wire for the LED strip actually goes to motor pin number 5 in the new Airbot F4 software. Also, I decided actually in the end to use an XSR instead of a XM Plus, just because I can get telemetry off it. But unfortunately with this flight controller, again you have to do a little mod. So you take it off the central pin on the back here, and then you route it to, I chose TX3, you can also use TX6, and you have to make sure that your S-Bus, your receiver is on UART1, and this is because it's the only hardware version, so you have to take it off the back of this to re-invert it. Okay, so next up will be just adding the last few components. Going to stick a low ESR capacitor, 35 volt, 1000 UF on it, and just some power to make sure that it's okay, and then we'll stick on the Rush VTX and the camera. Okay, so we've added a few more components on. I've put in the VTX, which is the Rush VTX. I've also put in the Runcam Micros Swift 2 camera, and I've just put it in on its metal frame, and I did actually change and have to put some screws through the bottom of the plate here. They didn't quite fit, so I had to kind of tap some or widen the hole slightly. The other problem with this Revo F4 flight controller is that although everything else works, the LEDs definitely have a problem, and I wasn't able to get the normal LEDs to work, so I have just connected up a red and a white, red at the rear, white at the front, 12 volt LED strip. I have a little 12 volt regulator for those, and they both operate off the same regulator. I also put between the PDB, which takes battery voltage, I put a small regulator to clean up the voltage on the way to the VTX, and then the VTX is powering the camera. I've also stuck on the capacitor, as I mentioned. The XSR is here and ready to go with the VTX cable. Very easy to stick on. And so just gotta finish it off, put it together, tidy away the wires. I'm pushing some of these wires underneath because there is a dirty plate underneath, so there is some room for wires down there. Okay. So that's it put together now. Just put the top on, tied up all the wires underneath, tied up, put with some normal insulation tape, the ESCs. Just use some cable ties with some heat shrink for the antenna, and wired the camera and the battery underneath, put on the board, the plate, the dirty plate, and that's it. Build complete, ready to fly.